We are on another one of our summer fun shots. We talked about doing swimming before. There's going to be another water-based one. So the question is, a lot of times, of course, people swim and they go underwater and they might notice that it's hard to see when they're underwater. So I just want to talk about why is that and what you might do to fix that. So first, what do we need to see? We need to have a lens. So we talked before about using parabolic mirrors as a lens, but you can instead, more commonly, we use like glass or something like that, where the light bends when it goes through. And so the whole purpose of the lens is to take the light rays that are maybe not coming toward each other and cause them to be focused down. That's what the lens in our eye does. And the way that that works is that when the light hits the surface of the lens, because the surface is curved, the light is not hitting it straight at normal incidence. It will then bend when it goes through that interface. And that's due to this well-known phenomenon that's called Snell's Law, which is shown here on this slide. So Snell's Law relates the angle at which you come in to the angle of which before an interface to the angle that you leave that interface, and it depends on the indices of refraction. So the index of refraction tells you about the speed in a material. The index of refraction is the speed of the light in that material divided by the speed of light in vacuum. And it ranges everywhere from 1, like in vacuum, or more or less in air, to something like 1.4 in water, or something like 1.5 in glass, something like that. And so that tells us how much the light will bend more when it goes from one material to another material. So I have an example of that here. So I just have a laser which is going through air at the top and then into water. And when I go at normal incidence straight down, that angle is 0. And so the angle is 0 on both sides. But as I tilt this down to here, for example, we see that in fact, so this is this angle of, I don't know, 50 degrees at the top, but at the bottom, it's only like 35 degrees or something like that, and that's because of Snell's law. So when it goes from where it's moving fast to where it's moving slow, then the light bends towards the normal, and if I go from the other direction, then it actually, when it goes from where it's moving slow, like the water, to the air, then it actually bends away from the normal. One thing you notice, though, if we go back to the formula, is that if the two indices of refraction were exactly the same, if n1 were equal to n2, then the two angles should be exactly the same. So we wouldn't actually get any bending in that case. So we can come over here, and this is one of my favorite demos. Okay, so I just have a little glass beaker here, and I have another glass beaker, and I have one that's filled with water, and I have one that's filled with oil. So I'm going to just put this beaker in each of these other beakers, and we're going to ask, what do you see? And here, you see the little beaker inside, no problem, right? It's easy to see. Even though the glass is transparent, you still see it because of the fact that I'm still getting this refraction off of the glass. If I put this into the water, you can still see that there's a beaker there. It's a little harder to see, but you can still see that it's there. Okay, let me just get rid of that then. Okay, now here's the best one. I'm going to put it into the oil. And when I put it into the oil and it's filled with oil, then it really completely disappears. And that's because the index of refraction, the speed of light in the glass, is almost exactly the same as the speed of light in the oil. They're different in the third decimal place. And so if you look very carefully, you can still see the ghosts. But really, basically, the thing has disappeared. OK, so what does this have to do, then, with swimming? So when you go in underwater, your eyes are normally designed to have air on the outside of them. And so we get the refraction on the outer surface of the lens because the light is bending when it goes from the air into the material of your lens. But when you're in water, the index of refraction in water is very, very similar to the index of refraction in your eye. And so basically, you don't get almost no refraction at that outer surface of the lens. It's all on the inner surface. So it becomes much harder to focus if you're underwater. So what can you do to fix that? Well, if you wear goggles, the purpose of goggles is to make sure that the material that's outside of the lens of your eye is air instead. So then that's how they're designed to operate. And so then if you're underwater and you wear goggles, you should be able to see, assuming there's enough light and it's not all murky water or something like that, you should be able to see really well and clearly.
Cool.
So useful things you can think about next time you're in the pool or just enjoy yourself.